We've already looked at these exponent properties on your foldable. Now we're going to add to it, and we're going to look at quotients. We're going to look at quotients with like bases, quotients raised to a power, and quotients raised to a negative power. The first one is quotient of like bases, and these are the two ways that a division problem will look. A basic division problem, and then of course as a fraction. And the operation you're going to use is keeping the base and then subtracting the exponents. So keep the base and subtract the exponents. Here's our first example. We have 4 to the negative 4th and 4 to the 8th. We're going to keep the base and subtract the exponents. So we keep the base again, and negative 4 minus 8, if you make a T-chart, 4 and 8 on the negative side, because they're on the same side, you add them, and you keep the negative symbol. So 4 to the negative 12th. You can't have a negative exponent, so we have to use the reciprocal and make it into a fraction, and the 12 has to go downstairs to become positive. So 1 over 4 to the 12th power. There are other ways that you could solve this. You could also have looked at the fact that there's a negative in the beginning problem, and you could have moved 4 to the negative 4th downstairs, leaving 4 to the 8th downstairs, and bringing the 4 to the negative 4th downstairs to make that 4 positive. Then you would use the product with like bases rule, and that would be 4 to the 8 plus 4. That would be a 4. And then 8 plus 4 obviously is 12, and you still are in the denominator, getting the same answer different ways. Here's the next example. We don't have like number bases, so we're going to bring them over. 4 fifths. We do have x's that are the same. We don't have an exponent for the bottom one, so we're going to put a 1 with it because there's one x. Then we're going to subtract the 3 and the 1. So x to the 3 minus 1. 4 fifths stays the same. Bring over the x. 3 minus 1 is 2. And there's nothing else we can solve. And the reason that we're able to subtract is because the top would have 4 times x times x times x. The bottom would have 5x. And the 4 fifths has to stay the same. And then we can cancel these out because they equal 1. And we're left with 2 x's on the top, no x's on the bottom, and we get the same answer doing it a different way. Here's the next example. We do have 5, the base, with the exponents that we can solve. So we have 5 to the negative 6 minus negative 9, and then x, let's put a 1 there again, raised to the 3 minus 1. This becomes a plus, so I'm going to rewrite my problem, negative 6 plus 9, and then I can go ahead and solve the x. 3 minus 1 is 2. If I make a T-chart for negative 6 plus 9, I would have positive and negative T-chart with negative 6 and positive 9. They're on different sides, so you find the difference. The difference would be 3. The 9 is bigger and it's positive, so it's positive 3. So that equals 5 to the 3rd power x to the 2nd. Here's our next section. fraction, the quotient raised to a power. So now we have the division problem with the parentheses raising it to another power. So we're kind of combining things. We have the division part where we would use subtraction, and we have the power part which would use multiplication. So this is what the rule is going to be. You have to distribute the exponent to both the numerator and the denominator, everything inside the fraction, and then you're going to apply the rules that you already know. So here's our first example. 5 to the third over 5 to the ninth. All of that is raised to the fifth power. So I'm going to start by distributing this 5 to everything in the fraction. And we multiply those. So we have 5 raised to the 3 times 5 over 5 to the 9 times 5. Then we can solve it. That would be 5 to the 15th power and 5 to the 45th power. We have like bases, so now we use our subtraction rule that goes with the quotients. And we have 5 raised to the 15 minus 45. And if you subtract that, well, let's make a t-chart first. We have 15 on the positive side, 45 on the negative side. And the difference between those is 30. And the negative is larger because of the 45, so it would be negative 30. So 5 to the negative 30 power. We can't have a negative exponent, so we have to write the reciprocal. So 1 over 5 to the 30th power. That would be our answer. The next problem, we have 4a to the third power over a to the ninth, all raised to the power of 5. So we're going to distribute. Everything in the fraction has to be distributed with that 5. So I'm going to put a 1 here to know that there is an exponent of 1 next to the 4. So I will draw there an arrow to everything inside the fraction. So I have 4 to the 5th power, a to the 3 times 5, all of that over a to the 9 times 5. So we have 4 to the 5th, a to the 15th, over a to the 45th. We're going to leave the 4, but we do have the a's that are like bases, so we can do the subtraction rule for the quotients. So 4a to the 15 minus 45, and we've already done this math problem, but I can still make a t-chart. 15 and 45. The difference is 30, and it's again negative, so negative 30. So now I have 4 to the 5th. I forgot to bring that over. 4 to the 5th power, a to the negative 30th power. And again, we can't have a negative exponent. So the 4, we're going to make a fraction. The 4 is going to stay where it is. The a has a negative attitude, so they have to move downstairs to become positive. That is a 3, and that would be your answer. The next example is quotients raised to a negative power, and we're going to kind of do the same thing. We're going to distribute and then apply the negative rule. And you'll see that it ends up flipping things over because of that negative rule. The first example, 5 to the third over 5 to the ninth, all raised to the negative 5th power. So I'm going to draw an arrow to everything inside my fraction. So I have 5 to the 3 times negative 5 over 5 to the 9 times negative 5. So I have 5 to the negative 15th over 5 to the negative 45th. Now I have negatives, and I have options here. I can go ahead and apply the negative rule by flipping them over, or I can use the subtraction rule from quotient. So I'm going to do that first. 5 to the negative 15 minus negative 45. We know that becomes 5 to the negative 15 plus 45. I can make a t-chart. And 15 is a negative, 45 is a positive. The difference, as we've been doing before, is 30. This time it's going to be positive because of that 45 on the positive side. So I have an answer of 5 to the 30th power. You could, at this point, flip them because of that negative rule, so you have options. So I'm going to do it that way over here. So if I flip those, they both have negative attitudes that actually would completely flip the fraction over. And then I'm going to apply the division rule. So that would be 5 to the 45th power minus 15. And still we have 5 to the 30th power, just done a different way. Here's the next example. I'm going to apply this negative 2 to everything inside the parentheses. I'm going to put a 1, so every term has an exponent. So we're going to distribute 1, 2, 3, 4 times. I'm going to go ahead, and that is going to be 6 to the negative second power, a to the negative 6th power, I'm skipping some steps now, over 3 to the negative 2nd power, a to the positive 8th power. Make sure that you understand how we got those. I just skipped the step of writing out the multiplication. So I have 6 over 3, and those are both to the negative 2nd power, but they're not the same bases. But I do have to flip them over because of the negative 2 exponent. The bad attitude has to go downstairs. So I'm going to go ahead and do that. 6 to the positive 2 on the bottom, 3 to the positive 2 on the top. Those negative attitudes have to go. And now I have a, and I'm going to use the subtraction rule, to the negative 6 minus 8. And that would equal, we're leaving everything in exponential form, so 3 to the 2nd, a, if you made a t-chart, negative 6 minus 8, both on the negative, that would be negative 14. Negative 14th power, my 4's keep messing up, all over 6 to the 2nd. Well, we have another negative exponent, so we have to move a to the negative 14th downstairs. So our final answer, 3 to the 2nd over 6 to the 2nd, a to the negative 14th. But I can't forget that I have the 3 and the 6, which can be simplified to 1/2. I am going to keep the 2 exponent for each of those. Oh, and I forgot I made that positive, so I would have a to the positive 14th power. So let me rewrite the final answer so it looks right. 1 to the 2nd over 2 to the 2nd, a to the positive 14th. That would be your final answer in exponential form. But I am going to go back to this part, and I could have easily changed the 6/3 to 1/2 at that point, but I'm not going to do that. I'm going to use my negative rule and move everybody and then solve it. So I would have 6 to the negative second has to go downstairs, 6 to the positive second. A to the negative 6 has to go downstairs, a to the 6th. I'm going to go to the denominator. 3 to the negative second has to go upstairs to become positive 2. And a to the 8th stays downstairs. Now I have different rules to apply, but I'm going to still get the same answer. I can look here and know that I already can do my 1 over 2, keeping them to the second power. And then I have a to the 6th plus 8. So I am still left with 1 to the second over 2 to the second power, a to the 14th.